Hello, today I'll talk about gas laws. The first gas law you'll learn is Boyle's law, and it talks about the relationship between the pressure and volume of a gas. And the Boyle's law states that when there's constant temperature, the pressure of a gas is inversely proportional to its volume. So, for example, if we had a gas that is initially at a volume of 4.0 liters and at a pressure of 2.0 atm, and the pressure increased to 4.0 atm, what would be the new volume? It's very simple. You just have to plug in the numbers. Just going to be 2.0 atm times 4.0 liters equals to 4.0 atm times x liters. And if we solve for x, it's going to be 2.0 liters. Alright, the next law we'll learn is Charles' law. It talks about at a constant pressure, the volume of gas is directly proportional to its temperature. So, for example, if there's a gas at 300 Kelvin with a volume of 5.0 liters, what would be its volume at 600 Kelvin? Again, we just plug in the numbers into the equation. 5.0 liters over 300 Kelvin equals to x liters over 600 Kelvin. And you should get an x value of 10.0 liters. There's a really important requirement for Charles' law though. The temperature must be at Kelvin. And by the way, Kelvin is Celsius plus 273. When you encounter a problem about Charles' law where pressure is constant but the volume temperature changes, you need to make sure your units of temperature are at Kelvin. Next, we're going to look at Avogadro's law. Avogadro's law states that at a constant temperature and pressure, the volume of a gas is directly proportional to the number of moles. So, for example, if we had 2.0 moles of gas that occupies 10.0 liters, how much volume will 4.0 moles of that gas occupy? Let's plug the numbers in again. So 10.0 liters over 2.0 moles equals to x liters over 4.0 moles. And for x, you should get 20.0 liters. And lastly, for Dalton's law of partial pressures, it states that the total pressure of a gas mixture is the sum of the partial pressures of its component. So this basically means that if you have a mixture of gas, for example, the air we breathe has different types of gases. Let's say, for example, it has O2 and N2. What this law is stating is basically that if O2 has a partial pressure of, for example, 1 atm and N2 had a pressure of 2 atm, then it's saying that the pressure of the air or the gas mixture is going to be 3 atm. Okay. Oh. So, yeah. These are all the laws you have to know. And let's just look, skim over these problems. First problem, a gas occupies a volume of 458 milliliters at a pressure of this much at a temperature of 295. And it says the pressure is changed and the volume becomes 477. So it's a question about pressure and volume, where the temperature remains constant. So immediately we know that this is about Boyle's law. So again, we're just gonna plug in the numbers to this equation. And for Boyle's law, by the way, if you are given a specific unit for the pressure, the answer has to be in that unit too. This question talks about a tube of gas at a room temperature of 22.44 degrees Celsius, volume of 10.6 milliliters, and it talks about a temperature increase. So we know that temperature is not constant, but the pressure remains constant, and we need to find a new volume. So this question talks about Charles' law, because it talks about the relationship between volume and temperature. So again, you're just going to plug in all of the numbers here, and you need to make sure the temperature is in Kelvin, by the way, for Charles' law. Yeah. And then let's look at the third example. 3 moles of a gas occupies 68 liters, and the temperature remains constant. And we want to find the new volume when the moles becomes 7.5. So this talks about moles of gas and volume, while temperature is constant. So you can tell that this question is about Avogadro's law. Again, plugging in the numbers are really easy, so I believe that you can do that by yourself. And last one is about partial pressure. So you immediately know that it's about Dalton's law. And it says there's a mixture of hydrogen and oxygen. And the pressure being exerted by these gases, so P total is 785. And if the partial pressure of the hydrogen is 395, then what is the partial pressure of the oxygen? Again, you plug in the numbers again, and if you subtract 785 by 395, it's going to be 390. Okay. And the last example is again about Dalton's partial pressure law, so I recommend you solve it by yourself.